Hello everybody, and welcome back to another math learning video. Today, I brought you guys this system of equations here where we have x1 plus 2x2 minus x3 is equal to 9, 3x1 plus x2 plus 2x3 is equal to 7, and 2x1 minus x2 plus x3 is equal to 0. And what we need to do is we need to solve the system of equations. So basically, for each of these variables here, we need to solve for x1, for x2, and x3, okay? So let's go ahead and do this. So how are we going to do this? Well, the method that I'm going to use is the matrices method, okay? So we are going to make an augmented matrix. So how do we do that? Well, matrix, you draw these two brackets here, and then you look at the coefficient of each variable, okay? So what is the coefficient? The coefficient is the number that the variable is being multiplied by. So here for x1, you may think there is no number that's being multiplied by. So you may think it's 0, but however, it is actually 1, okay? So because there's an invisible 1 in front of here, so its coefficient is 1. So I'm going to write 1 here. I'm going to actually make this whole thing bigger. So 1 here, and then the next coefficient is 2. And then here we have a negative 1, okay? Because look, we don't see anything, so there's a 1 here, but it's negative 1. And now let's go to the second row. 3 we have here. 1 and 2. And then the final row, 2, negative 1 again, and just 1. And now I'm going to create like a borderline here to separate the left side of the equations to their answers. So here we just write what the coefficients or what the values are on the right side, 970. Okay, so now we wrote out the matrix. But how does this help us solve for the variables? Well, what we need to do is we need to get this matrix into something called row reduction form. So what does that mean? Well, that means that in each row, so these are the rows, right? Row 1, row 2, and row 3. There needs to be a point. So starting from the first row, there needs to be a point on the left, and then all the other points under it have to be 0. Okay? So I'll show what this means first with the first row, okay? So basically for the first row, the first point here, we have a value here, but we need all the values under it to be 0. So how do we do that? Well, we do that by doing various calculations, okay? So what we can do is that we need to get rid of this 3 first of all, right? So what we can do to get rid of this 3 is that we can turn row 2 into row 2 minus 3 row 1, right? Row 1, right? Because if we subtract, so basically this is a legitimate way to change the rows up. There are various operations. This is one of them. If we subtract 3 times row 1 minus row 2, 3 is here. This 1 in row 1 would turn into 3, and then we subtract it from 3 here, and this will become 0, right? Okay, so let me write this out actually. So our row 2 is equal to 3, 1, 2, 7. Okay, and if we subtract 3 times row 1, that'll be row 1 is 3. This 2 here is 6. This negative 1 would be negative 3. And then the 7 would be 21. Okay? So let's go ahead and do the subtraction. So 3 minus 3 is 0. 1 minus 6 is negative 5. 2 minus negative 3 is 2 plus 3, right? So that gives us 5. And then 7 minus 21 is negative 14. And sorry, I just noticed that this 21 value here is not correct actually. So if you notice me making that mistake, I apologize before. This value here should be 9 times 3. okay? Because we multiply the whole first row by 3 here. So what is 9 times 3? It's 27 actually, not 21, okay? I apologize for that. So 7 minus 27 is negative 20, okay? So now we write in this new second row that we have. So let's write in the first row, first of all. 1, 2, negative 1, 9. We write in our new second row, 0, negative 5, 5, negative 20. Okay, so now we see that we have, so we want to get what's called a pivot point where this first value here, where all the values under it, so all the values under this one need to be 0, okay? So we already got the first value under it 0, so now we need to get the row 3 value 0. So how will we get the row 3 value 0? Well now, last time we got rid of the 3 by subtracting it by row 1 times 3. We'll get rid of this 2 in row 3 by subtracting row 3 by 2 times row 1, okay? So our row 3 is 2, negative 1, 1, and 0. And our row 1, 2 times our row 1 would be 2. 2 times 2 is 4. Negative 1 times 2 is negative 2. And 0 times, and 9 times 2 is 18. So then we subtract all this. So 2 minus 2 is 0. Negative 1 minus 4 is negative 5. 1 minus negative 2 is 1 plus 2 is 3. And 0 minus 18 is negative 18. So this is our new third row for now. 0, negative 5, 3, negative 18. Okay. So now we got our matrix closer to row reduction form in that the first pivot has only zeros under it. But now we need to look at the second row, and the first value that comes up, the negative 5 here, also needs to have all zeros under it. So that means that we need to get rid of this negative 5 that is right under it, right? So we need to get rid of the negative 5 in row 3. So how we do that? Well, we need to change row 3, so we can change row 3 by subtracting it simply by row 2, right? Since both of these values are negative 5, if we add them, or if we subtract them with one another, then they will cancel out, right? So our row 3 is equal to row 3 minus row 2, so our row 3 is 0, negative 5, 3, negative 18, minus 0, negative 5, 5, negative 20. Okay, so that'll be 0 minus 0 is 0, as it should be. Negative 5 minus negative 5 is 0. 3 minus 5 is negative 2, and negative 18 minus negative 20 is negative 18 plus 20, so that is 2, okay? So this is our new third row. So let me move this a little so I can draw the new matrix. So now we can put in our new third row. So 0, 0, negative 2, and 2, okay? Okay, so now we got exactly what we wanted. We got our matrix in row reduction form. So the first number in the first row is the pivot because there is no values under it. And the same goes for this, and same goes for negative 2 here, okay? So we have our 3 pivots here. So that's how we know it's in row reduction form. And now, how do we use this to find our variables that we're looking for, right? So there are various methods that you can go about with this. So one method is you can go into further, which I think is called reduced row reduction form or something like that. But that's not what I'm going to do. I prefer this method here where every column here corresponds to a variable. So this column here, the first column, corresponds to our variable of x1. Second column corresponds to x2. Third column corresponds to x3. And our last column is our solutions. And our solutions I'm going to call B, okay? So now, these values inside the matrix, they correspond to the coefficients of our variables. So now if we look at the third row, this means that 0x1 plus 0x2 minus 2x3 is equal to 2, right? However, if you multiply these two values by 0, they're just non-existent, so that means that negative 2x3 is equal to 2, right? So we can simply solve for x3 that way by dividing by negative 2. So we get that x3 is equal to negative 1, okay? That's how easy that is. So we already got our first variable. Okay, so now we have our value for x3, right? Equal to negative 1. So now let's look at the second row where 0, x1, I'm not going to write out the 0, negative 5, x2, plus 5, x3 is equal to negative 20. So now you may think we have two variables here, so how do we solve for them? Well, we already know that our x3 is equal to negative 1, so we just plug in negative 1 for our x3. Okay? That's equal to negative 20, so we get that negative 5x squared minus 5, because 5 times negative 1 is negative 5, is equal to negative 20. Now, add 5 to both sides. Just cancel out. We get that negative 5x squared is equal to negative 20 plus 5. Careful here, this is negative 15. Divided by negative 5. Sorry, I wrote x squared here. This is x to the 2, okay? Don't get confused. So we get that x to the 2 is equal to negative 15 divided by negative 5. And that is equal to 3, right? So now we have two of our variables. Now time to find the last one, our x1. So for that, let's use the first row. So 1x1, I'm just going to write x1 plus 2x2 minus 1x3 and minus x3 is equal to 9. So now plug in the variables that we know. X1 plus 2 times 3 minus negative 1 is equal to 9. So x1 plus 2 times 3 is 6. Negative 1 is positive 1. Equal to 9. 6 plus 1 is 7. Subtract 7 from both sides. Then we get that our x to the 1 is equal to 2, okay? So now we got our three variables that we were looking for. But whenever you work with the system equations, let's write our answer in this sort of matrix here, where our x1 comes first, our x2 comes second, and our x3 comes third. So we'll write like this. 2 to 2, 3, our x2, and then negative 1. Well, whenever we write our answer, we want to write it like this. Let's draw brackets, and then write x1, x2, x3, each getting their own row, and then write it equal to, and now write the actual values of x1, x2, and x3. So x1 is 2, x2 is 3, and x3 is negative 1. Okay, hopefully I didn't mix that up. So now, this is our answer theoretically, but we can always check. This is the beauty of these type of problems, that we can just plug in the x1, x2, and x3 for each of the equations here, and they all have to be correct. So let's check for the first one, x1 plus 2x2 minus x3. So that will be 2 plus 6 is equal to 8 minus negative 1, so plus 1 is equal to 9. Yes, that is correct. The second one, 3 times 2 is 6, plus 3, 9, minus 2 is 7, correct. And then 2 times 2 is 4, minus x2 is 3, so it's 1, plus negative 1 is 0. So yes, so plugging these values in makes all of these equations true. So that means that we have found the correct answer, okay? So that is how we solve for any system of equations, okay? So, thank you for watching this video. I hope you guys enjoyed it, and see you guys next time. Bye!